Alright, TGIF. Thank God it's Friday, and today we're going to wrap up our series for this week looking at the adjoint of a matrix. So, what is our objective for today? Today will be a simple one. Today we're going to simply find out how to form or how to find the adjoint of a matrix. That's all for today. So, how to write the adjoint of a matrix? Let's start looking at that. To form the adjoint of a matrix, this is what we really do. We switch the position of the elements in the major diagonal, and then we change the sign of the elements of the minor diagonal. Really and truly, that's the bottom line. So, how do we go about doing that? Simple. Supposing we have a matrix, and let me use a generic algebraic matrix. Let me say we have A, B, C, D. First thing, I put that bracket just for me. First thing you need to understand, or first thing you need to know, which diagonal is the major, which diagonal is the minor. So you see AD here, take a note of that, and remember that that is your major diagonal. Major diagonal. And you see CB, remember that this will be your minor diagonal. And that's just what it is. That's the name they gave to it. It has nothing to do with significance or importance or why it's minor, why it's major. No, that's just the name. Major diagonal N, right? So remember this. So your major diagonal is this one where I have AD. Sometimes it's also called the leading diagonal. So you will see leading diagonal, you will see major diagonal. I was taught as major, so I always remember it as major. But as you go in higher level institution, you'll get different connotations for it. They're all the same. Major, leading. Then you hear the minor. I've never heard non-leading, so I won't say that. So you have the minor diagonal and the major diagonal. So to form the adjoint, in other words, to find, let me use another color here, to find the adjoint of R, all you do, according to the rules that I have up there, you switch the positions of the elements in the major diagonal. So where A is, you put D. Where D was, A goes there. So this will end up being D, A, and then for the minor diagonal, you just change the sign. So C will become negative and B will become negative. And I repeat, you change the sign. So if it was negative, when you find the adjoint, guess what? It will become positive. That's all there is to it. That's all there is to it. So let's go. Let's see if we could have some. Oh, well, look at that. I have some examples here. So let me see if I could clean up this here. Quickly. Right. So for example, if I have matrix Q equal to 2, 6, 4, 8, that's matrix Q. When you look at the adjoint of that, here what happens? You see? The 8 switches with the 2, and the 4 and the 6, they just change this sign. That's all. That's all. So let's see if we could do these examples here. So I will quickly do these. I mean, of course, you could join me. You have some to do after, but you could quickly join me if you want. I will quickly write the adjoint. So O is this. So the adjoint of O will actually be equal to, I switch the positions of the major. So that will be G, E, and then for the minor, I just switch signs. So minus T, minus T. That's it. This is the adjoint of O. Let's look at the adjoint of K now. So the adjoint of K is actually switch the position of the leading. So that will be 6, 2, and then you see this 3 here is negative. So for the adjoint, it will be positive. And the 9 will become negative. Story done. And the adjoint for D, is equal to switch the positions and the leading. So we have 8 here now and 12 here instead. And since the two signs are negative on the minor, then guess what? For the adjoint, they will both be positive. Easy breezy, easy does it. Moving on. Here is your practice time. So write the following now. Write the adjoint of the following. And of course, this is where you could pause the video and attempt it and then repause it or unpause it or rewind, what do you say? Fast forward, I don't know. Do something and then it will continue running. Press play. So I will move on, of course. So the adjoint of W will actually be, no sticking for me, it will be F4 minus Y positive 7. It's a really nice process. I actually like doing this. It's quite fun. And it's a pity there's no component in maths where you just have to do this. You have to, this is just part of a whole. So the adjoint of L now is actually equal to 4, 10, 5, minus 8. And last but not least, I hope I'm taking this thing so easy for granted that I'm making careless mistake. It will be sad to post up this video and then when I'm looking at it for myself, I realize, oh shit, I make a mistake. Say what? And then we have, for here now, we will have 1, 4. This 1 here will become positive now because it's negative. So this is positive 1, and the 3 will become negative 3. And that's the adjoint of those matrices. And yeah, basically that's how you do it. That's your practice. I wonder if I had a right, so that should bring us to the end of today's video. And what you need to remember for when it comes to the adjoint, of course, this is only a means to an end. In next week's set of series, you're going to see why do we use the adjoint. And sad to say, sometimes people mix up the adjoint with transposition and sometimes even with scalar multiplication. But we're going to see why do we use the adjoint. I could give you a heads up. We do need it when we're finding the inverse of a matrix. But I say no more. As for now, enjoy the rest of your weekend, enjoy the rest of your day. Subscribe if you haven't as yet, like and turn on that notification video and share it with your friends so that they will learn maths as good as you. Until then, you take care.